of the analysis paper is why amplifiers. Okay, that is what we'll be learning the first topic. And what are the characteristics of amplifier? What is amplifier trade-off? Right. Then we will be learning about single stage amplifier, how to construct the single stage amplifiers, and what are the types of single stage amplifiers. Okay. In that, we will be learning about common source amplifier. That is the first amplifier which you will be learning, common source. And then what are the common after common source amplifier? What are the various types of loads we use? Okay, which includes resistive load, diode connected loads, current source load, diode load, and source generation loads. Okay, and then we'll go to the second type of amplifier, that is common source amplifiers, common drain amplifiers. They are otherwise called as source followers, right? Followed by that, we'll also analyze the resistive load, current source load, and voltage division source follower, right? Then the last type, that is common gate amplifier. We will analyze all these amplifiers. The last topic is cascode amplifier or combination amplifier. So this is the overall view of the module, first module. Okay. So today's class we'll be seeing why do you need an amplifier. Can anybody tell why do you need an amplifier? We'll start with Isaac. Isaac, why do you need an amplifier?
Also, to make the signal stronger.
Isaac, little more, please, louder.
Can you hear me, sir?
Why do you need an amplifier?
Sir, to strengthen the signal.
Strengthen the signal. Good. Okay. Or in other words,
To increase the amplitude of the signal.
yeah, increase the amplitude. Not only the amplitude, you can also increase the frequency and the other components, phase. Right. Shaikh Baba, please be on time to class. Why amplifiers? Right. That's what we are looking at. Now, amplifiers are the very basic building block of the analog as well as digital circuits, right? Without amplifiers, you will not be able to uh, go ahead sending the signal in, into the system, right? You will not be able to send a real-time signal into any system without an amplifier. Okay, that important is it. If you want to process any real-time signal, amplifier plays a huge role. Right? Now, when you look at signals, you have analog domain signals as well as digital domain signals. Okay. These are two domains, but both of them requires these amplifiers in order to construct or build a system, right? Now, as Isaac said, the first and foremost thing of an amplifier is it amplifies the weak signal, right? Weak in the sense the strength of the signal, right? Every signal has got a strength. Obviously, you will understand when you use mobile, if your strength of your mobile is not good, signal is not good, you will not be able to properly hear the voice. Yes, so that indicates that it is a weak signal. So that weak signal has to be amplified, right? So that is the first and foremost reason why we go for amplifier, right? The second important thing is the effect of noise. Okay, how do you define noise? How do you define noise? Ahadian, what is noise? According to signals, how do you define noise? Ahadian,
Sir,
how do you define noise, Ahadian?
it's like a disturbance, sir.
I think your voice is very less. Can you please a little more raise your voice?
Sir, can you hear me, sir?
How do you define noise?
It's like a disturbance, sir.
Can you come back, please?
Sir, can you hear me, sir?
How do you define noise?
It's like a disturbance, sir. External factor.
It's the, okay, it is an unwanted signal,
Yeah, yeah.
right? In simple, it's an unwanted signal which is coming into the system, which corrupts the original signal, right? We will study in detail about various types of noise as we uh, go down the syllabus. Okay. And it also, for the digital system, it also provides a proper logic level, right? For a digital system, it provides a particular logic level because digital operates in logic level, either 1 or 0. If you don't attain the 1 or 0 logic level, automatically the signal gets distorted or the signal doesn't reach its original value. So for that purpose, amplifiers are used. These are some of the reasons why we go for amplifier. Okay. Another important thing why do we go is amplifiers play a very crucial role in feedback systems. Right now, feedback systems we will study it in Unit 4 is a very important element in order to build a system, right? If you look at systems, there are two types of systems. One is called open system, the other one is closed system, right? So if you want to control the system, you need to make the system to be a closed system, right? So then only the required performance can be obtained. In that particular area, amplifiers plays a very important role. Okay, so we will look at low frequency performance amplifiers. Okay, and then we will also see how to analyze the amplifiers with respect to the parameters. Okay, so this is the reason why we are studying this particular topic called why amplifiers. Okay, now we will see what is the characteristics of amplifier. So this is the next topic, amplifiers characteristics. Okay. When you look at characteristics, generally the characteristics is plotted between the output and input. Okay, the output and input is given as y and x respectively. Okay, for an ideal amplifier. Okay, whenever you give an input x, you get an output y. Okay, but it is not exact replica. There will be a gain factor alpha 1. Okay, y is equal to alpha 1 into x. This is the basic expression for the characteristics of an ideal amplifier, right? Where it will be a linear function. Okay, linear function means it is proportionately increasing. Okay, it will be proportionately increasing with respect to y is equal to alpha 1 into x, right? This is the basic ideal amplifier characteristics. Okay, when they are when you are dealing with MCQ, please be careful this particular word. This is the key word. It's a linear function, ideal op amp or ideal amplifier, right? Now when it comes to the, is that clear? So this graph of characteristics is plotted between y and x, where y is the output and x is the input. Now when you look at the real time, okay, it is a non-linear function. Okay, or practically, when you talk about the input output characteristics, it is a non-linear function. Okay. So y is equal to, it will be a non-linear function where it will vary from x1 to x2 range. In between this particular range, your whole plot is done. Okay. So this is the region of non-linearity. This particular area is the region for non-linearity for an practical amplifier. Okay. Now we are going to derive how do you get this non-linear function? Linear function is already defined. Y is equal to alpha 1 into x. Okay, this alpha 1 is the gain of the amplifier. So this is the ideal case. But for non-linear, how will you get the expression? Okay, that's what we'll be dealing in this class. Okay, is it clear so far? So what we have discussed is, why do you need an amplifier? Okay, and then we saw what is the characteristics, right? We saw the characteristics in two dimensions. With respect to an ideal op amp, it will be a linear function. With respect to a non-linear or a practical op amp, it will be a non-linear function. Now we will see how do you how is the graph plotted. It is generally done by linear approximation. Okay, the expression is done using linear approximation technique. Okay, where we draw the real time as well as the ideal case and take the tangential value of it. Okay, so this tangential line will determine the operating point. This particular point is the operating point of the amplifier, determines the operating point of the device, right? And then with this operating point, you will determine the characteristics, right? This is the basic thing we do. Now we will see how do you get the non-linear function for an amplifier, right? How do you get it as uh, we are using a Taylor series expression. All of you would have seen the binomial expression. You have seen about binomial. You should have definitely learned about binomial expression. So from there, we take up this Taylor series expression in order to find the nonlinear amplifier expression. We take this Taylor series into consideration. Now, what is Taylor series is, if you don't know, no problem. The expression of y is given as a function of x. Okay, and plus it's a non-linear, so it has to vary non-linearly. Plus x f, this function is differentiated with respect to x naught into x minus x naught. Okay, plus double differentiation of x divided by 2 factorial into x minus x naught the whole squared, etc., up to fn of x naught divided by n factorial into x minus x naught of n. This is the basic expression for a Taylor series for a non-linear function. Is this clear? Okay. If you have notes, you can take down this note, because when you come in person, you will be taking down the notes. So this is the basic expression. Now from this expression, we have to derive the expression for nonlinear function. Now how do you do that? We will look. Is this clear so far? All of you, can I have a response?
Yes, sir.
Can you please raise your hand? Thank you. How many of you have raised? Joel has raised. Ashika. What about the remaining? Please raise your hands if you understood, or if you want me to repeat. Isaac, is it okay? You have any doubts? Okay, thank you. So we have seen, thank you, Mark, and drop your hands. We have seen two type of characteristics for the amplifiers. One is with respect to the ideal condition, where you have your, Isaac, you can drop your hands down. Where we have seen the linearity function y is equal to alpha 1 into f of x, and the nonlinear function, right? So nonlinear function is expressed in terms of Taylor series. Now what is this f of x? This f of x is given as alpha of n. Okay, this is the gain factor, which is given by f dash fn x naught divided by n factorial. So this full value is replaced by alpha. Okay, so this full value is replaced by alpha. It is n times, then it is alpha n. Okay, so how do you write the expression? The expression changes out as, this is f naught, so this becomes alpha naught. Okay, and this is alpha 1, okay, into this particular variable, right? And this is alpha 2 into x minus x naught the whole square. This is etc. This is alpha n into x minus x naught of n, right? So the whole expression is changed to with respect to alpha. Okay. Now, when you're going to define an amplifier, right? So we are taking the first order differential value. For higher terms, we are neglecting for the analysis purpose. What we are going to do is we are going to remove the higher order terms. Okay, we're just considering the first degree value. So when you take the first degree value, it is only till this particular value. Okay, we are just going to consider alpha is equal to alpha naught plus alpha 1 into x minus x naught. We ignore the higher order terms. Hence, we are getting this expression y is approximately equal to alpha naught plus alpha 1 into x minus x naught. Okay, this is a very important expression which is used for defining the non-linear amplifier characteristics, right? So when you make it as two operating points, one is alpha naught, which is the operating biasing point, and alpha 1 is the small signal gain. Okay, what is small signal gain, large signal gain? All those things we will detail as we go down the course, right? So we can replace this expression as delta of y. Okay, delta means a small change in the output variable is given as y minus, okay, y is nothing but, how do you get y? Any idea? Small change in y is given as y minus f of x naught. Okay, this is a very important expression where your delta y is made approximately equal to alpha 1 into small change in delta x. Okay, so please be careful. You have made it to the standard format. Okay, this is how you rewrite the expression and get it. Please derive it by yourself and see if you understand this. Okay, so this is the uh, which goes to the normal expression of y is equal to alpha into x. Okay, since it is a linear, non-linear characteristics, I told you there will be 2 points of operating x naught, x1, and x2 point. So the linearity has to be maintained. So this is the delta x value, okay, change in x value. So you get the final expression x1 into delta x. Okay. Is this clear? So this is the basic expression for non-linear amplifier characteristics. I will repeat it. We start off with the Taylor series where f naught of x, f dash of x into x minus x naught, etc. Replace it with alpha. We get this expression. We remove the higher terms in order to make the analysis simple, and then we find out delta y is equal to alpha 1 into delta x. Okay, this is the basic nonlinear operating amplifier characteristic expression. Okay, is it clear so far? So we have seen amplifier with respect to its characteristics in its ideal characteristics and the nonlinear characteristics. Now we'll go to the next topic, amplifier trade-off. Okay. So we have seen two topics as of now. One is why amplifiers. The second topic is amplifiers characteristics. Now we will go to the next topic, amplifiers trade-off. Okay. Trade-off is a phenomenon. Okay. When does the trade-off come is when you are going to buy, say you're going to buy a mobile. Okay. What is the major trade-off you will have? Price. Good. Very good, Joel. The major trade-off is price. Any other trade-offs? First thing trade-off comes is money. Okay, right. That's good. Any other trade-offs? Quality, brand, great. Isaac Daniel, look, okay. Specification, features. Yeah, Ashwin, specification. That's right. Yeah. Similarly, for amplifier design, okay, there are a lot of trade-offs. Okay, I'll take the first trade-off as Joel said, money. The first trade-off for me, as far as the amplifier is concerned, is the speed. Okay, and the major one is the gain. So the major one, if you are a design engineer, gain would be the major one. For me, speed is also an important one. The second one would be voltage, supply voltage. What is the supply voltage of your amplifier? That's the second major one. Third one is your voltage swing. Okay. Basically, these two are very, very important as far as a designer is concerned. That is the voltage swing. They are major parameters and the gain. Right? Gain is very, very important for an amplifier. Right? There are other trade-offs, like we will be studying that also when you are designing it. It is the input-output impedance, power, noise, and linearity. Linearity we already saw, right? So these are the major trade-off parameters, right? And obviously, when you increase one, definitely the other one will decrease. Okay. If you're a design engineer, you tell me that I've got a greater gain, automatically the linearity is going to decrease. Okay, and also the input-output impedance is going to affect majorly the input-output. And if you tell that my supply voltage is less, my linearity is going to affect. You tell my voltage swing is higher, noise swing is going to increase. If you make my speed higher, it is going to affect the linearity. Okay, so that is always a trade-off. When you compromise on one, automatically you go for brand, the price increases, right? Yes, Joel? Apple phone, brand is good, but the cost is high, right? Yes or no? What is it? No port subject, sir. It's the number of ports subject to, sir. What do you mean by that, Joel? Is the number of ports subjective? Joel, I didn't get it. Input output ports. Input output ports in amplifiers. Input output or ports for amplifier is subjective, sir. Yes, you have input output ports. What do you mean by subjective? I'm not getting. Uh, Obviously, you have an input to an amplifier, you have an output to an amplifier. But what do you mean by subjective? I'm not getting. What do you mean by that? Like we have channels in amplifiers. Channels are altogether different. That you do it in mux. In amplifier, generally you give an input, you have an amplification factor. That is based on the gain of the amplifier. The channel comes into play when you deal with mux. Okay, that's where you have channels and you have multiple channeling of values. That's altogether a different problem. Here, input output, what I've told is the impedance. Okay. High input impedance and low output impedance. That's the general ideal case, right? So these are the amplifier trade-offs. right? Now we will study about the single stage amplifier. This is the first amplifier we are going to study. Single stage amplifier. Okay, there are also multi-stage, but in single stage, generally, there are four major types of amplifiers. One is called the common source. This is the most predominantly used amplifier. The next one is common drain. It's otherwise called as source follower. Okay. The third type is common gate. Okay. So these are three terminals: source, drain, and gate. When you make three of them common, there are three major types, right? And the last category is called the cascode and folded cascode type. Okay. It's called the cascode and folded cascode type. There are advantages as well as disadvantages of each amplifier. We will study that in detail, as well as their utilization depends upon the design requirements. Okay. So this is how other types of amplifiers. You please keep in mind there are four, and in that we will stage by stage study one. So today's class we will start with the first type of amplifier, that is called common source amplifier. Okay, so far we have studied the introduction of why we are going for amplifiers, and then we saw what is the characteristics of an amplifier, and then we saw amplifier trade-off. And the last thing we saw is what are the types of amplifiers. There are four types. In that, the first category is called common source amplifier. Is that clear? So, what is a common source amplifier? Common source amplifier is the most basic amplifier that is used in order to make the transistor work. Right? Now, how does a common source amplifier looks like? System is getting hammered. Okay. Now, when you look at an amplifier, there are a lot of challenges in building up a very simple amplifier. Okay. The first and the foremost challenge would be uh, what is the design specification, right? Similarly, for a common source amplifier, can you tell me what do you mean by a common source amplifier? Oh, we'll ask Shaikh. Shaikh, what do you mean by a common source amplifier? Definitely, you would have studied this type of amplifiers in your UG. Shaikh, you there? Shaikh, any idea what is a common source amplifier? Shaikh, are you there now? Kindly respond. Mm, Shaikh, are you there? Can I have a response from you? Shaikh, Baba, Shaikh, are you there? Kindly respond now. We're waiting for you. Okay, I've got a next guy. Ashwin, Ashwin, there are two Ashwins here. Francis Ashwin. No, I'll go to the other Ashwin. Ashwin Raja. Ashwin, what? Any idea what is a common source amplifier? Can you give it in the chat? The voice is very less. Common source amplifier. Ashwin, what do you mean by a common source amplifier? Fast. Just type it, no problem. Ashwin, can I have a response, please? In your chat, all of you, give your answers on your chat. I'll give you 1 minute. Fast. What do you mean by common source amplifier? Done? Please give your answers on the chat. Source is grounded. Good. Any other answer? That's right answer. Source is grounded. Any other answers? Source is grounded. That's all. Francis Ashwin has told output is obtained from the drain. Ashika. Great. That's good. Still, quite a few are there. Ahatyan, Ashwin, Raja, Sri, and Kavi. Hey, only 3 have responded, man. 6 or 9 are there in the class. Can I have a response? What is common source? 19 tells it the source is grounded. Good. Any other answers? Mr. I still have responses waiting from Hatya, Hatyan, and Sri Ashwin. Source is grounded. Okay. Any other answers? Last, Hatyan. Sir, are you there? Hatyan. Your response, please. We are waiting for your response. Go ahead. Right. So a common source amplifier input is connected to the gate, okay, and output is taken across the drain. Is that clear? The input is taken is connected to the gate, and output is taken from the drain terminal. Okay, so for an NMOS, okay, your N, as all of you said, source is grounded, okay, but the input is connected to the gate and output is connected to drain. I think Ashika told the output is connected to the drain, right? That's a good answer. Other than that, I'm blank, sir. It's okay, Agati. Is that clear? So this is the first modeled MOS. The next modeled MOS is PMOS, right? In PMOS, the source will be like this. The arrow will be coming in, right? And the output is drain and input is gate. So this is the structuring of a source amplifier for the two type of MOS, that is PMOS and NMOS, right? Now, when you look at the source amplifier, all your analysis will be divided into two groups. Okay, the first one is called without source generative. Okay, which means that there is no body effect coming into play, right? So I want all of you, when you come for the next class, please make a study about what is body effect. Okay, when you come for the next class, just make a study and come on what is body effect. Okay, we will see in detail later, but the two type of source amplifiers that we are going to study will be categorized into with body effect, that is called, so without body effect and with body effect. That is source generative. The circuit will have a resistance in the, will not have a resistance, that is you don't consider the body effect coming into play, and with uh, resistance means that it is source generated. Okay, so what is that? Please make a study of yourself and come. It is with respect to body effect. Okay, that is with respect to transistor. So this is the first type, and we are going to study the source amplifier with respect to loads. There are 4 type of loads we are going to study in detail. We'll see that in the next class. Okay. So to sum up, what we have learned for the day. We have studied first why an amplifier is required. We saw amplifiers are used for both digital as well as analog circuit as the basic building block for any system is concerned. And then we saw the needs of it, and then we saw what are the characteristics of an amplifier. In that, we have analyzed the characteristics of an amplifier with respect to what is the ideal condition for an characteristics of an amplifier, and then the practical or a real-time amplifiers characteristics, and we have derived it using Taylor series. And then we saw the amplifiers trade-off. What is the trade-off of an amplifier? And the last thing we saw was the types of amplifiers. In that, we have seen four major types: common source, common drain, common gate, and then the cascoded amplifier. And then we saw what is a common source amplifier. We saw how does a common source amplifiers are categorized with respect to body effect, that is source generated circuits and source degenerated circuit. Okay. I have uploaded the notes in the class for your reference. Please refer it.